Hello, everyone, and welcome to Growing Investigation 1, starting with problem 1.1 here on page 7 of your textbook. Our learning target for 1.1 is I will begin to explore exponential growth. You see our homework down here for this investigation. 1.1 homework, 1 and 2, 22 through 40 even, and number 41. 1.2 is 4 through 11, 42 and 43, and 1.3 is number 13, 15 through 21, and 45 through 47. Now, the due dates for these are not listed on here because they will change from year to year, but I will have this file listed under the investigation 1 showing what dates all of the homework is due. So let's take a look. 1.1, we are making ballots with introducing exponential functions, and we learned in finding Pythagoras that if we squared something or took, say, the number 2 to the coefficient, or I'm sorry, not coefficient, the exponent of 2, 2 squared, that we would take 2 times 2, and that would equal 4. We also learned about cubing, which if we would take 2 to the exponent of 3, we would have 2 times 2 times 2, or 8. And as you can see, the first time we multiply 2 by itself, we have a growth of 2. But the second time we do it, we have a growth of 4. And if we do it another time, we'll have a growth of 8, and so on and so forth. It keeps doubling each time. And so although the growth at the beginning wasn't very fast, it gets a lot quicker, a lot larger the further down the line we go. So in our textbook, it says Chen is the secretary of the Student Government Association. He's making ballots for a meeting. Chen starts by cutting a sheet of paper in half. Then he stacks the 2 pieces and cuts them in half again. With 4 pieces now, he stacks them and cuts them in half. By repeating this process, he makes smaller and smaller paper ballots. Let's take a look at a video that might help with this, or not.
Where are the ballots? I don't know. They've got to be around here somewhere. Help me look around.
I don't see them. There's only a blank sheet of paper here.
I must have left them at home.
As secretary of the student government, it's your job to have ballots prepared for today's election.
I know what to do. I'll improvise and cut and count. That way we have enough ballots. That makes 2 ballots. 4.
I'll record the results in a table. Then we can predict the number of ballots after any number of cuts, so we know when to stop.
I hope everything is ready, because there's a crowd at the end of the hallway heading this way.
Hurry! We're almost out of time.
256.
I think you overdid it. How many cuts did you make?
All right, so how many cuts were made to make the 256 ballots? Well, working with exponents, we're going to go ahead and find that out. Now, in your lab sheet for 1.1, it's going to have a table in there where you can fill this out. It says after each cut, Chen counts the ballots and records the results in a table. So after his first cut, they have 2 ballots. After the second cut, there are 4 ballots. So then after the third cut, how many ballots do you think there'll be? And go ahead and fill out the complete table, which goes out to, I believe, 10 on the lab sheet. Anyway, he wants to predict the number of ballots after any number of cuts. So we want to be looking for a pattern. How can you predict the number of ballots, say, after 8 cuts? Or how can you predict how many cuts to make if we needed 128 ballots, or as they said in the video, 256 ballots? So we need to be able to describe the pattern of change and how many ballots are there after n number of cuts, n being a variable of any number, a dependent variable. So how do you find the entries for each table as we take a look at problem 1.1? So it says to make a table to show the number of ballots after each of the first 5 cuts. As I said, that's lab sheet 1.1, which you can find on the website as well as picking up in the classroom. So how do we find each of the entries for that table? And then what is the relationship between the number of ballots and the previous number of ballots? What's happening there? How are we seeing a pattern with that? And Then we want to get to a point where we can explain that relationship in terms of the number of cuts, that we know X number of cuts will give us Y number of ballots. So we need to look for a pattern in the way the number of ballots change with each cut, use our observations, and fill out the table up to 10 cuts. So then we want to graph the data, and that is also on the lab sheet. There'll be a graph there. And then write an equation. We need to write an equation that represents the relationship between the number of ballots and the number of cuts. Okay? You learned how to write equations and come up with those when we did linear functions. So now let's learn it with exponential functions as well. So what patterns do you see that you might be able to create an equation to predict or solve for? How does the growth pattern show up in the graph and the equation? Is this relationship linear? Explain why or why not. Then on C, suppose Chin could make 20 cuts. How many ballots would he have? Well, you have to think about that and use your equation. How many ballots would he have if he could make 40 cuts? Which is a lot. And then how many cuts would it take to make just 500 ballots? So, after filling out the table, doing your graph, and coming up with an equation, we should be able to have an idea how to more easily answer the questions here in section C. So that's 1.1. That's the problem you'll need to work on with your team. If you want to get a head start on it, you can. And then the homework we'll be doing in class for 1.1 will be numbers 1 and 2, and then the even numbers from 22 to 40, as well as number 41. So we'll see you in class tomorrow, and let me know what questions you have regarding this information.